Hi, this video is an introduction to two new concepts for you in your laboratory. One of the concepts is called the momentum, and the other concept is called the kinetic energy. And what these two concepts do is they quantify mass in motion. They put mass and motion together. If you think about it, motion is described by velocity. And if you know the velocity of something, that is definitely interesting. But different objects can have the same velocity. The other concept that that's in this mix is called mass. And two different objects can have the same mass but different motions. And it turns out that there are important reasons to consider how much material and how much motion together. And that's what momentum and kinetic energy do. So momentum is one of the ways to quantify mass in motion. And momentum, the way you calculate it, is you take the amount of mass and you multiply by the amount of motion. So it's sort of the simplest combination of the two different concepts, mass and velocity, that you can have. Momentum is a vector. And the direction of the momentum is the same as the direction of the velocity. So, for example, here, what if I have an object? So here's an object. It is 2 kilograms. And let's say that it's moving downwards with a velocity of 5 meters per second. Then the momentum equals 2 kilograms times 5 meters per second down. And what this is 2 times 5 is 10, and the units are kilograms times meters per second. And remember that momentum is a vector, and the direction of the momentum vector is the same as the direction of the motion or the direction of the velocity. So the momentum is also down in this case. So let's go and compare that with the kinetic energy. The kinetic energy, the way you calculate it is you take the number 1/2, right, 0.5, and then you multiply by the mass, and you multiply by the speed squared. So in the example above, we can do this, right? So in the example above, I've got 1/2 times the mass. The mass is 2 kilograms. And then I multiply times the speed squared. So the speed and the velocity, they're related. If you remember, what the speed is it's just how fast, and you ignore the direction. So the speed is 5 meters per second, and we have to square it. Squaring it means you just multiply by all of the details of the speed, including the units. You multiply it by it twice. And when you calculate this, 1/2 of 2 is 1. So 1 times 5 is 25. And the units are kilograms, right? Here's a kilogram. A meter per second times a meter per second is a meter squared per second squared. And it turns out that this combination of units has a very special name, and that name is capital J. And its capital J is the joule. So we're going to study this unit of energy, right, the next lab as well, next week, or the week after next, because the next week you have a test over the first 4 labs, right? Okay, so this is the kinetic energy and the momentum. An interesting thing to do, and you're going to wonder about it during your lab a little bit, is I have this 2 kilogram object moving at 5 meters per second down. And we calculated that the momentum was 10 kilograms meters per second down. But what if I had this 2 kilogram object moving at twice the speed? If speed is doubled, you can see that the momentum is doubled. And the way that you see that is instead of 2 kilograms times 5 meters per second giving 10 kilograms meters per second, if the speed gets doubled, then the speed is not 5 meters per second, it's 10 meters per second. And 2 kilograms times 10 meters per second instead is going to give you 20, right? 20 kilograms meters per second down. So if the speed is doubled, the momentum is doubled. But if the speed is doubled, it turns out that the kinetic energy is not doubled, it's quadrupled. And the reason is because whenever you calculate the kinetic energy, you take 1/2 times the mass times the speed squared. So little v stands for velocity. I know, but you should know that when you're calculating the kinetic energy, what's important to put here is the speed, right? So if the speed is doubled speed is twice v, right? It's just 2 times v. And the kinetic energy with a doubled speed is equal to 1/2 m twice v all squared. And when you calculate this, this is 1/2 m 4v squared, right? All multiplied. And this is equal to 4 times 1/2 mv squared. And if you look at this, this is 4 times the old kinetic energy, right? And this is the sense in which the kinetic energy is quadrupled if the speed is doubled. Okay, so you're going to learn some more topics as well in this lab.